so again, on your own here, graph y equals x plus 2, y equals x plus 4, y equals x plus 5. And I'll do the same thing. Okay, give you like one more minute here to finish those up. Yeah. Lucy can wait, try and graph, okay? Let's get a graph here, Sean. Come on, baby. Decent there. Dylan, what's your slope? No, what's your y-intercept? What's your slope? What's the number in front? A 1 or 1 over 1, right? So from that point, where should you go? There you go. Keep going. Okay, lots of points. Remember that. Good stuff. Oh, I see you're jumping ahead. Sorry, I was going to use. Sorry, let me just take a look at these real quick. Okay, cool. Yes, we'll get to that point. Sorry. Yes. Okay, looking good. All right. He's looking pretty good. Okay, cool. So now, looks like most people got these things graphed. So let's take a look. Or I'll go ahead and mark it. Let's finish up. I'll let you finish up. We have 30 more seconds here. Bless you. And use your slopes. Use your slopes and your intercepts, right? This is a slope of 1 over 1, 1 over 1, 1 over 1 there. No, I'm just putting that up there for people that maybe want to see it, kind of thing. Okay. With those graphs, okay, it asked us, beginning with the graph of y equals x plus 2, so beginning with this graph right here, how could this line be moved or changed to create the graph of y equals x plus 4? So what could we do to this line to make it look like this one? What needs to be done? How should it change? How can we move this line to make it look like this one? They look pretty close already, don't they? What's already the same about these two lines? The slopes, right? The slope of this one's 1, the slope of this one's 1. Yeah, but what's different? The y-intercepts. So how can we move this one so that it has the same slope and y-intercept as this one? It's the same line. Move it how much? 2 places in which direction? Yeah, move it up 2, right? Move y equals x plus 2 up 2 units. That's all I really need to say, right? And then it'll be the exact same line. Okay, then it'll be the exact same line. All right, how about think about this same line right here. What could we do to this line here if we wanted to make it this line right here? How should we move it? So again, Mark, if we have this line right here, Mark, and I want to move it so that it looks like this line right here, how should we move it? Again, I want to take this one and move it to make it look like this one. How should we move it?
Move
Yes, move it up 3. Exactly right. Move y equals x plus 2 up 3 units. Oops, I'm off the screen. There we go. So in other words, if I had f of x was equal to x plus 2, if I had a function equal to x plus 2, so y equals x plus 2, f of x equals x plus 2, you get the idea. If I wanted to move it up 2, I could say f of x, plus 2, and that would, keep writing this wrong. Like that, okay? I could take my function and add 2 to it, and that would shift it up 2 units. Same thing here. If I wanted to write f of x here equals x plus 2, and I want to make it match this one, I would do f of x plus 3. That would shift it up 3 units. Okay, so if I want to move my function up 2, if I want to take this line and move it up 2, I can write the function plus 2. If I want to take my function here and shift it up 3, like Mark said to do, we can do f of x plus 3. Okay, so that's the transformation. We're shifting it up 2 or 3. Okay, now, you guys probably already have an idea, right, about this. You guys can figure out patterns and things, right? If I wanted to move my function down, what would I do instead? Yeah, subtract a number, exactly right. So if I wanted to change my function, if I wanted to make it move down, I would subtract a number here, and that would make my function move down. So let's, in fact, talk about that on the next page here. Okay, so on the next page, if you would please, graph that same y equals x plus 2, then graph y equals x minus 1, then graph y equals x minus 4. Okay, quickly graph those if you don't mind. Okay, so quickly graph these 3 lines, okay, on your paper there. Womp womp. Be like 1 more minute or so here, 1 more minute. That's okay. You can fix it, that's okay. That was good. Aaron just mentioned that. Mark's almost done there too. Yeah, you got 1 more minute. Like 30 more seconds here. 30 more seconds. We're going to go over these questions now. All right, so this is what your graph should look like. Okay, beginning with beginning of the graph, y equals x plus 2, how can the line be moved or changed to create the graph of y equals x minus 1? So what do you say? Let's go to Dylan. If we start with this graph, how can we move it or change it to make it look like this graph? Down how much? Is it hard to see?
Wow, that's big.
Okay. I did this wrong.
Okay, okay, gotcha. How many down we have to go?
3.
Yes, exactly right. Move y equals x plus 2 down 3. You can also see it right here, right? Look at the lines. Both of them have the same slope of 1. One has plus 2, one has minus 1. What's the difference between positive 2 and negative 1? The difference is 3, right? 3 units. Okay, so it's moving 3 units downward there to go from a positive 2 to negative 1. All right? How about the next one? If I want to take y equals x plus 2 and move it to match up with the y equals x minus 4 here, how we move it? Let's go to Kendall. What do you say, Kendall? So how would we take this one and move it to match this one right here?
Move it down.
Yes, exactly right. Move y equals x plus 2 down 6. We could say units, I guess, here. Okay, and again, you can see the difference, right? If I'm going from a positive 2 to a negative 4, that's a change of negative 6, right? Okay, so number 3. Based on your responses to let's get rid of that in there. Based on your responses to questions numbers 1 and 2, okay, what effect does increasing the value of b in y equals mx plus b have on the graph of the line? Okay, so if we increase the value of b, if we raise b's value, okay, how does that affect the line when we graph it? What's that going to do to our line? If we increase b, what will that do to it? Hannah?
We'll change it.
Okay, and specifically it's increasing, and we'll change it in what way?
If it's increasing, it'll make it go up.
Well, it'll make what go up? The b, or therefore the line will go up. Okay, exactly right. So what effect does increasing the value of b in y equals mx plus b have on the graph of the line? Okay, if you increase b, this will move the line up. Okay? If you increase b, this will move the line up. Wow, that looks like a sloppy handwriting. Sorry, guys. Okay, move the line up. Exactly right. Okay? And of course, then, if we decrease b, then what will be the result there, Daniel? So in other words, look here. We had 2, right? And there was the line. Then we decreased b to negative 1, and there was the line. And then we decreased b to negative 4, and there was the line. So what happens if we decrease b? What happens to the line? Yeah, it moves down or it gets lower. Yeah, that's right, exactly right. If you decrease b, this will move the line down. Okay? And in fact, the line will move down the exact amount that you lower b by. Okay? So if you decrease b by 5, how much will the line go down by? If you decrease b by 5, how much will the line go down by? 5. Yeah, exactly 5. Exactly 5. If you increase b by 20, how much will the line go up by? Not a trick question. If I increase b by 20, 20, right, okay. All right, turn the page. So that's what happens, that's what b does, okay? So if you change b. Oh, okay. The 3? Or this one right here? Okay. We'll get to it. Hang on, so let me just finish my little thought here, and then I'll get you back. So, we now understand, or hopefully we have an idea, right, that y equals mx plus b, that b, when you change it, when you change b, if you increase b, it moves the line up. If you decrease b, it moves the line down. So we can like change where our line is on the graph, or on our coordinates here, by adding or changing b. Now we're going to see what happens when we change m. So we're going to keep b the same, we're going to change m. Last time, we kept m the same. M was always 1, we were changing b. Now we're going to change our m's, and keep our b's the same. Okay, question, Carson, and then Dylan will get you.
So if it's like the m, right, it's like 2 over 1.
Mm-hmm.
That,
Mm-hmm.
and then it says like, it's the beginning with the graph y equals x plus 1. How can I find the user change to create the graph of y equals 2x plus 1? Would it be you move up 1 unit, or would you move up 2? You're
I see what you're saying. We'll get to it in a second. Think about that, and we'll answer that question just a little bit. I want everyone else right now to graph it, and then think about it. We'll talk about what we can say there for how the line changes. Okay? But for right now, go ahead, guys. I would like, guys and gals, I'd like you to go ahead and graph these 3 lines. Okay? So again, now the y-intercepts are staying the same, but it's the slopes that are changing. So right, the slope here is 1 over 1. This one's 2 over 1. This one's 4 over 1. Okay, so go ahead and quickly graph those. Okay, go ahead. Get to graphing. Oh, where'd my... Let's see, I put my ruler down. Yep. Let's finish this and I'll let you go. Okay, just these next couple questions here, and then you can go. Okay, because I just want to make sure you get the point here first. So we can't necessarily move it, but what's changing about it, though? Go ahead. What were you going to say? What were you going to say?
I'm going to say it's like kind of like increasing.
What's increasing? What property or characteristic of the line is increasing? You're right. Something is increasing. When you did your hands like this and kind of thing. Yes, exactly right. Sorry. Bumping around here. Good. Okay. Cool. All right. Great. Let's keep looking here then. So we've got our 3 graphs. Beginning with the graph of y equals x plus 1. How can the line be moved or changed to create the graph of y equals 2x plus 1? So, looking here to here, what's changed about our line? What has changed there? Let's go to Erica. What's changed about the line here? From here to here. How's it different? The y-intercept is still the same, right? But what's different, though?
The second one's like going higher. Right?
Yes, okay, or steeper, you could say. Exactly right. Now, let's look at how that changed here. Right? Here, the slope was what? You can say it, Erica. What's the slope here? What? Well, or what's the number I could put in front, though?
1.
A 1. And what's the number in front here?
2.
Aha. So we changed from a 1 to a 2, and the slope got steeper. Okay? So how can the line be moved or changed? Okay, we can, let's see here. Make the slope of y equals x plus 1 steeper. Okay, steeper. It gets like it increases faster. Okay, or you could even say increase the slope.
Could you just say move y equals x plus 1 up 1 unit?
If we move this up 1 unit, it would have a y-intercept of 2, right?
Yeah.
The y-intercept is not 2. So good question, but unfortunately no. The y-intercept will stay the same. Okay? But in a sense, though, Carson, you have kind of like a right idea because there are things moving up here, right? I mean, this line is kind of moving up, but it's not just like moving straight up. It's actually kind of like turning a little bit, you might say. Okay? Anyway. Okay, how about then y equals x plus 1 to y equals x plus 4?
Pivoting.
Okay, yeah, you can say pivoting. That's another way to say it. Yep. And again, we'll just say, make the slope of y equals x plus 1 steeper again, right? And increased, okay? Increase the slope. Oh, hi, thank you. Okay? You mess up? Uh-oh, well.
Yeah, I just realized that.
Okay, well that's good. Now you know it for the future. I'm sorry. Okay. Bathroom, yes. Now you can go. Okay, thank you for waiting. All right, one more page here, I think, for us to do together. Well, maybe 2 more here. Okay, we'll see. Yeah, the third one will probably have you guys work on your own, I think. All right, number 3, go ahead, graph them. 1, 2, 3. Oh my goodness, we did. Shoot, you're right. Thank you. I missed it. Daggone. Okay, my bad. All right, sorry, folks. Number 2, thank you. Yes, graph those real quick. 1, 2, 3. Okay. It's a lot. This is a lot. We'll see, Ella. Just finish this up, okay? Yep. You have a question, Matt, you said? All right, hang on. Let me get this graphed, and it'll be right there. Okay, lots of practice graphing today, right? All right, Matt. Okay, question. Okay, but if we move it to the right, it's still not going to be quite the right slope, though, right? If we move it right, that's what do you mean by move it right? Like just take it and move it, just shift it right? Or do you mean like stretch it to the right? Right. I see what you're trying to say. I think I see what you're trying to say here, but it's not like. It's not quite that, because if we just move every point to the right too, it wouldn't like line up here still. See, because like it's flattening out some. So we wouldn't want to say it's just moving right too. Okay, it's a little bit different than that. Say like stretch or something like that. Yep, use those. Yep, and with this information. There's your K, there's your N, there's your P. Given this, then which one is going to be which? Okay. All right, your graph should look something like this. Okay. So with this graph, compare it to this graph again. All right, Simon, what's the difference? How can we change this line to make it look like this line? What do we have to do?
You'd have to add that half.
Okay, so put a 1/2 in front of that x there. Okay, so really like multiply the x by a half, right, or something like that. What do we see? What do you notice changes when we change from 1 to 1/2? How does the line kind of change how it looks here? What's decreasing? The slope is decreasing. Yeah. So the slope decreases. Okay, or you could say the line gets flatter. Okay, so the line gets flatter. And then from 1 to 1/4, what's happening there? The slope is still what? The slope what? Decreases, and again the line gets flatter as well. Okay? What's the flattest line you can have? What's the slope of a horizontal line? 0, right? So as our slopes get closer to 0, as our slopes go closer and closer to 0, right? 1 is not as close as 1/2, and then 1/4 is even closer. So 1, then 1/2, then 1/4. Those are getting closer and closer to 0, and so the lines, they flatten out, right, as the slope changes. Okay? So based on your responses to these two questions here, what effect does increasing the value of m in y equals mx plus b have on the graph of the line? So if we increase m, how does that affect the line? What does it do? Yeah, Ben?
It changes the slope.
Okay. How does the slope change? It increases it. Yep. Okay. And makes it steeper. Yep. Okay. So increasing m makes the slope increase or get steeper. Okay? Oh gosh. Thank you, sir. Okay? Increasing m makes the slope increase or get steeper. All right, what then happens if we decrease m? What happens if we decrease m? It makes the slope flatter, right? So it decreasing m makes the slope decrease or gets flatter. Okay, more flat. Or get flatter, I guess. Get flatter. Makes it flatter. Okay? All right. So let's graph these three here. Okay? +1, and then slope of -1. And I'll plot these here real quick for us. I think this is just a little too much. One, two, three, four, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Okay, now that our slopes are all negative, what are our lines doing? Now that our slopes are all negative, our lines are what? Go ahead, Scott.
They're all going back.
They're all going what?
Like, to the left. Can I use the bathroom?
Hang on, we've got to get this question answered right first before you go. What's happening to all these lines? They are what?
Going to the left, the negative side, and also down.
Yes, decreasing, we'll say. They are decreasing, right? Okay. So what effect does a negative... Yeah, you can go ahead. What effect does a negative value of m... Why are there two m's? What effect does a negative value of m have on the graph of y equals mx plus b? When you have a negative slope, the line decreases. And I'm going to say if m is less than 0, because that's the same idea of saying negative, right? The line decreases if m is less than 0. Okay? So, conclusions. In your own words, describe the effects of changing the values of b. What effects are caused? What happens when you increase b? What happens when you decrease b? What properties of the graphs is changing? What properties of the graph remains unchanged? So again, if you just change the values of b, okay, let's say if we increase b, what happens? If you increase b, if you increase that b and your y equals mx plus b, what happens to the line again? What does it do? Okay, line moves up. Okay. Anything else that changes? Or maybe something that doesn't change? If you change b, what doesn't change? Ben?
Your intercept, the y-intercept.
Well, if we change b, b is the y-intercept. So that's going to change. So if we increase b, the line moves up, the y-intercept changes.
Oh, the slope.
The slope stays the same, right?
I was thinking if you change the slope, then I had it reversed.
Yes, exactly. Because we were just talking about changing the slope here too, so I understand. Slope stays the same if you increase your b. Okay, what happens if we decrease b? Okay, if we decrease b, someone who's here. Okay, if we decrease b, come on, man, give me. Caden, what happens if we decrease b? Pass! You're killing me, Caden. All right, Reagan, help us out.
Line moves down.
Yeah, line moves down. Yeah, line moves down. You got it. Okay, so if you decrease b, the line will move down. What we can say about the y-intercept? The y-intercept will change, right? And the slope stays the same. Because we're only changing the b in that case. Okay, in your own words, describe the effects of changing the values of m. What happens if we increase m? What happens to the line? It does what?
Moves up.
No, moving up or down is the y-intercept, Dylan. What is it? How does the slope change? I mean, I can kind of see what you're saying. If you increase m, it does kind of move up. Like it gets what? What happens to the slope? If you increase your slope, the slope gets steeper. Okay. I know it's kind of a weirder way to describe it. So slope gets steeper. If we decrease m, what happens to the slope? Slope gets flatter. More flat. I don't know if flatter is a word. I should probably say more flat. Okay. We have to be kind of careful here with this because this is only dealing with if m is greater than 0. So if you have positive slopes and you increase a positive slope, it gets more steep. If you decrease a positive slope, that means if it gets closer to 0, it gets more flat. But if m is less than 0, okay, and you increase it, well, then the slope actually gets more flat. And if you decrease m, then the slope gets steeper. Okay? So your slope, whether it's steeper or less steep, really depends on how far it is from 0. If you have a positive slope and you increase it, you're getting further from 0, and your slope's going to get steeper. Okay? It'll be more and more like vertical looking. If you're a positive slope and you decrease, that means you're getting closer to 0. Your slope gets flatter, right? Whereas here, if your slope is already negative and you increase, that means you get more. You're getting closer to 0, so your slope gets more flat. And if you're already negative and you decrease it even more, as you get more negative, slope gets steeper. Okay? A more negative slope gets steeper. Okay? By the way, if your slope is positive, does that mean the line is increasing or decreasing? A positive slope means your line is increasing or decreasing. Increasing. If you have a negative slope, then the line will be what? Decreasing. Okay? All right. So these are some of the key, transformations that we should understand about lines. Okay? We can kind of manipulate lines around now with the intercepts. If we want to move lines up or down, we can just adjust the intercepts. Or if we want to make lines steeper or less steep, we make them either get further from 0 to make them steeper, or closer to 0 if we want to make them less steep. Okay. Flip over to the back and go ahead and try and answer these questions. Okay? These will be homework if you did not finish them. If you're already done, you can feel free to work on 10 marks or something like that, and I'll come around and help you with that. Okay? So the rest of the time, please work on this. This will be your homework, and then, of course, you can work on some of your 10 marks too. Okay?
Wait, what are we on?